To test an interaction, there should generally be some sort of theory that guides your rationale for testing an interaction. And I talked about this several weeks ago, and I should have talked about this right when we started from the get-go today. But there, Torre asked, if you look at your data, what would cue you in to maybe there's an interaction here, maybe something else is going on? And it's a great question because there is something that should cue you into that. And I mentioned this weeks ago, but in the context of not knowing what moderation is, it probably doesn't make a whole lot of sense. What might you think in your data would cue you into the fact that there is something going on that might be an interaction?
So the correlations might give something.
Okay, correlations,
Yeah, so like
especially between various variables, right? It's tough to break it down when you've got a bunch of bivariate correlations, though, right? What is our main uh, assumption when it comes to basic regression analysis? We have several assumptions. What is our first and foremost assumption? Say that again. Okay, so maybe not the first, but yeah, independence of observations is one. The one that I have kind of hammered home, I feel like maybe I haven't.
influence of X on Y.
No, not necessarily. Yes, it's something about the residuals, and what is it about the residuals? Normally distributed, or what we call homogeneity of variance, right? So you might have homogeneous variance, you might have heteroskedasticity, right? And so what is heteroskedasticity? We might have, if we have something like this, we look at our data, does that look like, if we had just a basic kind of scatter plot, does that look like homogeneous or heterogeneous variance? And what we mean by homogeneous or heterogeneous variance is, does the variance right here, are all of these bad? Is the variance right here different than the variance right here and the variance right here? What do you guys think? They look very much the same, right? You kind of have these confidence bands right here, and they look about the same. And that's homogeneity of variance, right? You've got variance that seems to have this nice spread. And of course, it might not follow this beautiful linear kind of thing, but then sometimes you have something like this. And is the variance right here the same as the variance right here, as judged by circles? No, right? Like, it's very different. This is called what? Yeah, heteroskedasticity. That's right. That's exactly what it is. Now, this could be for any number of reasons, right? This could be because you have a problem in your data, but it could also be because we have some sort of relationship between X and Y that's like this. And it's because as we move further out on some other variable, this starts to happen, right? These residuals start to diverge. And that is an excellent indicator of some sort of moderation going on in your analysis. The relationship between X and Y is different based on some other variable in the model, something that we're not accounting for. And right now, we can't tell what we're not accounting for, but we can see that as we get further out, something is happening, right? Something is amiss. And you can make a case for, we have this heteroskedasticity, which means as we get further out, X is not as precise a predictor of Y because something is affecting X at higher and lower levels, right? And that is your kind of basis for sometimes fishing for moderation, right? Trying to figure out, is there a way, I hate to use the term fishing, but is there a thing that's causing this relationship? And sometimes theories, science, happens by saying there's something seems amiss here. What could that be? And ideally, you find data that seems amiss and you have theory that guides you to what might be causing this, right? And then you test that interaction as a possibility. Fishing is the wrong word. I'm sorry, I should use fishing. But you find an issue and assume that there is some sort of an interaction that would tighten up the precision of this model, right? And that's exactly what an interaction is. All right, so let's get back to our data here. I screwed something up, and I'm not sure where I screwed this up. So I am going to reform my interactions quick. I'm just going to dump both of these. Because I must have done something. Everybody else had different coefficients than I had, right? They were all the same? So it wasn't me that screwed up? Okay, hold on a second here. Transform, compute. That's low. Okay. Transform, compute. I just want to make sure that I have high here. Ah, thank you. Oops. Okay. So let's all open Excel. Let's start a new Excel sheet. Everybody have Excel open? We good to go? All right. So we're going to need a range of x, right? X range. We're going to need our x slope. We are going to need our m slope. We're going to need our x by m slope. And all I'm doing is putting the things that are going to be in our regression equation, and we're going to need an intercept. Now, technically, we can have x1, x2, x3, x4, a whole bunch of x slopes, right? As long as our variables are centered, we don't have to worry about including them in this regression model. We only have to worry about x, m, and x times m and our intercept, right? Because everything else will be multiplied by 0 and it will be canceled out of our regression equation. We also are going to need this. High m and low m. Those are values that we're going to pick out later on because we are going to set those things at high and low levels. All right, so yes. Zoom. Better?
Much better.
Okay. Now the wonderful thing with Excel is we don't have to go back and forth calculating high and low levels and form a new or run a new analysis each time. We can use our slopes and we can say that those slopes change as a function of whatever. So what we're going to do here is we're going to call this mean m. And in mean m, m is set to 0, right? So our regression equation should be y equals, and remember, these are all going to be values of y. Remember when we calculated our curvilinear effects, all of those were actually values of y. They were equal something. So let's go equals. Our regression equation is what? What's our basic regression equation? Say that again. Intercept. Somebody said intercept, right? Intercept plus what? Okay, let's take our first b. So our first b is going to be this slope. We're going to put the slope here, the b of x, right? Times what? Yep, it's going to be x, and that's going to be our range of x, right? Let's do that. I'm going to click up here so that I can keep typing. Plus what? M slope. We can do that. Right here is M slope times what? Where do we get our M, our range for M? Where? High and low. Not yet. If we're talking, what box are we in for M? Where are we at? What box of M are we in? We're gonna have a high M, a low M, and a mean M, and we're in the mean M box, right? What is our mean of M right now? 0. So let's set it at 0, which means technically you don't even need this in the model. You could delete it out, but that's fine, right? Plus what? We have another slope here, right? This slope times what? Okay, times this times 0. We hit enter. Okay, and this of course is going to say 0 because we have nothing put in here at all. What is our range of x? Can somebody tell me what the range of x is? X is what variable again? Okay, so if x is distress tolerance, let's come up here to where we did the distress tolerance stuff. And here is our, this is also important. Let's remember our standard deviation for impulsivity is 0.79. Distress tolerance, standard deviation, or mean is 0, as it should be. And our range is what? -2 to, let's just call it +2, just to make it easy. It's not quite +2, and it's a little bit more than -2, but let's go -2. Then we can go equals, and we can kind of make this something. Let's just go plus 0.5. It'll add a half for each one. Oops. Plus. I should put a plus sign in there. All right, grab that, drag it down a little bit. Stop. I'm going to move that back up right there. So we have -2 to 2. Does that make sense? Are we all tracking? Who is not tracking right now? We're all right over there? All right. Let's fix this equation because there's some problems with that equation, right? The equation is technically right, but what do we have to do to make sure that things don't go haywire on us? What's that? We do dollar signs. There we go. Yeah. So we need a $ after F, a $ after 2, and that will lock in this spot, right? We don't want that to move. A $ after D, but we don't want to lock in the range because we want to be able to get this full range of D, right? $ after F, $ after 4.
Just do F4.
F4 will add. Oh.
Then if you click it again.
How do you F4 on a Mac? All right. So anyway, we can do that. We're missing our slopes. What is our slope? Let's flip back over here. For this, what we want is actually the basic regression model, okay? Analyze. We don't want to look at high. We don't want to look at low. We don't want to worry about any of that. We want the plain linear model. So let's start from scratch in our model building process here. We have center, drinks, age, and sex. Those aren't incorporated into our regression model in Excel. Is that okay? It is okay, because if we had drinks in here, it would be drinks times 0, and age times 0, and sex times 0, right? They would cancel out, and we wouldn't have to worry about it. So we're not going to add them in, but we'll leave them in here as covariates because that's important. They do affect the intercept, right? Next step, we want to add in centered impulsivity, centered distress tolerance, and centered impulsivity by distress tolerance. I'm not going to break this up by a whole bunch of steps. I just want to throw all these in together because right now all I want are the coefficients, right? Are we all caught up? Are we tracking right now? Anyone not tracking? Say that again? Sure. So in block 1, I just have drinks, age, and sex all centered. Yep. And in block 2, centered impulsivity, centered distress tolerance, and the centered impulsivity by centered distress tolerance interaction. Yep. We hit go. We scroll down to our final regression model right here. Notice none of these things really have changed from what they were before. But what we really want is to get these 3 things and our constant. Our constant is 0.943. Let's put it in as our intercept. 0.943. Notice that when we don't have any slopes, .943 is all that we have, right? That's our mean at x. Oh, I messed something up here, didn't I? F8 should also have dollar signs by it, because we don't want the intercept to be taken off on us. All right. So we have that. What is our x slope? What is the slope of distress tolerance? Negative 0.178. What's going to happen when I hit enter here? It's going to change the mean of m. All of them or just one? It's going to change them all, and are they all going to be the same? No, right? That is our new slope of m when, or I mean our slope of x when m is held constant at 0, right? All right. What is our slope of m? It is what? 0.13, is that what I heard? Oh, we'll go with 0.13, that's fine. All right, when I hit enter here, how is this going to change? It's not. Why not? Multiplied by 0, perfect. What is my intercept? Minus 0.077. When I hit enter, will things change over here? If I did things right, they shouldn't. All right. Okay, perfect. So we can graph this right now, right? Let's highlight this. Let's go insert, chart, line. There it is. Looks beautiful. Let's tie this. Let's go select data. Select data. And our horizontal axis category labels, we want that to be our range of x, right? Our line's not going to change. It's just going to change these numbers down here to match these up here. Are we all tracking? That is our slope of x when m is held constant at 0, right? When m is held constant at its mean, That is the relationship between distress tolerance and alcohol problems. As distress tolerance increases, alcohol problems decreases, right? And vice versa. Now we want to know what happens when impulsivity is high. What is high impulsivity? What is 1 standard deviation above? Minus 0.79. We can put minus 0.79 right there. And that means that 1 standard deviation, so technically we're saying that you don't have to worry about moving means at this point. We're just going to move standard deviations, right? We're just saying like, this is what a high standard deviation is. This is what a low standard deviation is. We're not trying to adjust means. So we can do high and low. We can do high being positive and low being negative, right? All right, so we set those. Let's call this low M, and let's call this high M. What do we do next? We need to make regression equations for these right here, right? Let's do high M first. So click in mean M, grab the corner, and pull it over. Let's just move our regression equation over into this block. But now, what did we have for M in everything under mean M? What did we put in there? Plugged it in. Zero, yeah. Yeah, we threw 0 in there, right? If we want it to be high M, we're just going to use what we put in here as high M, okay? So where we have 0, let's come over here. Let's delete that. Let's say, no, it's this. Again, we have 0 here. Let's delete that. Nope, it's this. So it's H2. Let's hold it constant at H2 for our equation, right? So now everybody's going to be set to 1 standard deviation above. We hit enter. And you should get 1.523. Grab this, pull it down. And now we can add that line to our graph, right? Let's click on our graph, click select data. Let's add series 2. And our values for series 2 are right here. We hit enter, we get a new line that comes in. So at high impulsivity, we see a steeper slope than we see at mean levels of impulsivity, right? Now remember, we interpreted that before as distress tolerance is more important for people with high impulsivity. Let's look and see what happens for low impulsivity. Let's click here. Let's pull this over. Are we all caught up before I keep going here? Everybody have a slope now for high impulsivity and mean impulsivity?
A couple of us are struggling with that equation. We're getting the same numbers as we had for mean to n.
Okay. So where there could be 2 reasons for that, Kelly. Either you haven't put anything in under high M and low M for that point. Okay.
I think when I identified it, I have
one of the zeros still there. Anyone else? How are we doing? Good to go? Rebecca's good to go? Sam, how you doing? Good? Anybody seen the movie Glass yet? I heard some yeses and some nos. Who has seen it? Just Daniel? Kelly, are we caught up?
Not yet.
All right.
Even Jacob doesn't seem to be able to figure out what I've done wrong here. That's so strange, 'cause it's correctly there.
Dollar sign. No. Your dollar sign's wrong. So that should be before the D. And when you dragged it, it moved. So it should be before the D, not an enter. And now grab that and kind of drag it down. All right. Now grab it. Perfect. You should be good to go. All right. So we now have our two lines up there. We're going to build our regression equation for our last one. Right here, we are going to substitute 0 for what? Low m, right? So let's click on low m. Let's put in our dollar sign for I and our dollar sign before 2. And the same thing here. Remove that. Click in here and put our dollar sign and our dollar sign. Any other changes that we need to make? Nope. Are we good to go? Everybody got, that's what your first value should be, 1.07. Everybody have 1.07? Aaron, Kelly, how we doing?
Working on it.
Oh, I suppose you guys had to plot your line quick, huh? How are we coming over there? No? Aaron, Kelly, how we doing?
Working on it. I think I have it. About to see if the numbers match. Okay, I think I'm there.
We are there. We're at yes, yes, yes. Does anybody listen to reply all?
Absolutely, and yes, sir, yes, yes.
All right. Okay, so do you have this next equation plugged in then, Kelly? Are we good here?
Yep.
All right.
I'm there.
Once we're there, grab it, drag it down. There it is. Next step is what? Plug our line in. So we go here, we go select data. We add a series, right? And we throw this in. There we go. And now that you've looked at these, or you can look at these, how would you explain this?
The slope becomes lesser when we have a high value of the moderator.
Yeah.
Usually at a high value of the moderator, the effect is weaker, while at the low value of the moderator, the effect is stronger.
Is stronger, yeah. Another way to think about this is that when distress tolerance is high, impulsivity doesn't matter, right? Look at high distress tolerance. All of the impulsivity intercepts at high distress tolerance, and keep in mind when I say intercepts, everything here is an intercept at a various level, right? So at high distress tolerance, impulsivity doesn't matter. Your level of impulsivity is all the same, right? When it comes to predicting, when it comes to level of number of alcohol problems. However, when distress tolerance is low, then impulsivity matters a lot because your alcohol problems can vary from about 1 to about 1.6, right? We can flip this graph. It's very easy to flip this graph. Let's do it. Let's see if this looks different if we flip our graph. How do we go about doing that?
Change the x and m.
Yeah, we just change the x and m. So let's go 0.13 minus 0.18. We have to change one other thing here, though, don't we? What's that? We have to change our high and low. And so what is, let's jump back over here. Let's find out what our standard deviations are for distress tolerance. Standard deviation for distress tolerance is 0.88. And what is our range for impulsivity? We have -1 to about 3. Okay, so let's go 0.88 and -0.88. And let's change this. Let's leave the range. It doesn't really matter. They're pretty close, right? Just for looking at it anyway. What does this chart tell us? So this bottom value is now what? It's now impulsivity. It was distress tolerance. We've just flipped this chart. And so when distress tolerance is low, impulsivity is a very strong predictor of alcohol problems. When distress tolerance is high, the relationship between impulsivity and problems is diminished, right? Let's go back over to our analysis in SPSS and see if that's correct. If we wanted to look at this opposite of how we've done it in the past, what would we do? We're now, what we have effectively changed what x and m are, right? So now for x, we're interested in impulsivity as x. Y never changes, right? But that means that we have to redo everything that we did for m. What did we do for m before? We made high-low values, and then we made a new interactions, right? So let's make new high values and low values for m, and in this case, m is distress tolerance, and we're going to add and subtract 0.88 from distress tolerance. So let's go transform, compute, high dist equals distress tolerance minus 0.88, right? That will give me my high value. Transform, compute. Low distress tolerance is plus 0.88. Go ahead. Transform, compute. We now have to make our new interactions, right? Which is going to be the centered impulsivity times our new high distress tolerance. So let's go imp by h dist. And transform, compute, low distress tolerance, imp by L dist, right? Are we all tracking?
Can you kind of go back a step?
Yeah.
With all the
So,
different-
first make high distress tolerance. Did we do that? Who has not made high distress tolerance yet? Ashley? To make high distress tolerance, you just add, or subtract 0.88 from the centered distress tolerance. We good? Now low distress tolerance. Who has not made low distress tolerance yet? To make low distress tolerance, we just add 0.88 distress tolerance to our centered distress tolerance variable. Then we form the new interactions. High distress tolerance times centered impulsivity. and then low distress tolerance times centered impulsivity. Who has all of their interactions? Who does not have all of their interactions built?
One more.
I'm almost
Okay, cool.
Good to go.
Good to go? Okay, so we just ran this model where we had centered impulsivity, centered distress tolerance, and centered impulsivity by distress tolerance, right? So that model's going to be over there. Let's remove these two centered things. We're going to keep our centered impulsivity because we're now interested in impulsivity as X, right? We will never change impulsivity. We will let distress tolerance change impulsivity for us. What do we want to look at first? High distress tolerance or low distress tolerance? High, perfect. We're going to add in high distress tolerance and the interaction between impulsivity and high distress tolerance. We tracking? We hit go. Just based on our graph, at high distress tolerance, should impulsivity now be higher than when distress tolerance is at its mean or lower than when distress tolerance is at its mean? Let's look at our graph again. So here is when distress tolerance is at its mean. Here is when distress tolerance is high. Which of those correlations is higher? The mean, right? So the correlation should be less. Let's see if we're right. We'll be right. Actually, real quick, I'm going to jump up here. Here's what impulsivity is when distress tolerance is at its mean. It's 0.129. Should be less than 0.129, right? Scroll down. Here is when it's held constant at its mean, 0.064. Here's the really important thing. The p-value is 0.274. That means at high levels of distress tolerance, impulsivity doesn't even predict alcohol problems. For you clinical folks, that's an important thing because you can say, if we can target a person's distress tolerance, we can remove the relationship between impulsivity and alcohol problems, right? Yeah, we can turn down that volume knob. And trust me when I say impulsivity is strongly associated with alcohol problems. So anyway, that also means that if we look at low impulsive or low distress tolerance, what should we expect? Anybody? A higher relationship between impulsivity and alcohol problems. So let's remove high distress tolerance and let's add in low distress tolerance and the interaction between impulsivity and low distress tolerance. And our slope of impulsivity on distress tolerance at mean levels was again what? I thought it was 0.13. Wasn't it 0.13? 0.13. So this should be greater or less than 0.13? Higher, right? Yep, greater than. And impulsivity, it is 0.198. So here is our range of relationships between impulsivity and alcohol use. At low levels, the correlation between impulsivity and alcohol use is what? 0.6. At high levels of distress tolerance, the correlation between impulsivity and alcohol problems is 0.6. When distress tolerance is low, the correlation is 0.2, right? So we have this range of relationships between impulsivity and alcohol problems, and it's represented by this graph. This is not a statistically significant relationship. This is, and this one is, and it's stronger, which means as distress tolerance goes away, the relationship between impulsivity and alcohol problems gets stronger. The volume gets turned up, right? Does that make sense? Yeah. There's one other weird issue here, and that is we just picked a number, right? We just picked one standard deviation. What if you want to know exactly when that variable becomes non-significant? Well, we can do that too. So I've put this graph on on web courses for you guys, but we can look at the regions of significance for these effects. I'm not going to have you guys make this one because it is a complicated formula, but you can download this. Don't download it right now. Just watch what I do, okay? I'm going to go into ARM 3. It's in here. And we have, anybody see a graph that says ROS? There it is. So this is a graph that I made because I was a nerdy graduate student that liked to do stuff like this. And so in this graph, our range of, you actually put your range of M, which is the range of possible values for mediation, right? And so we're going to go with -2. We'll add 0.5 to it. That works. All right, what was our slope of impulsivity?
The regular one?
Yeah.
Minus 0.178.
No, I don't think so. Oh, 0.17. No, I don't think so. Impulsivity, when everything is held constant at its mean. Wasn't it 0.13?
Oh, the flip one, yes.
0.13. What is the interaction? What is the slope for our interaction?
Minus 0.077.
Minus 0.077. These things over here are a little bit different because what we're doing here now is calculating confidence bands. So let's flip back over and let's run our regression again. Analyze, regression, linear. And we're gonna run the basic regression model. So centered impulsivity, centered distress tolerance, centered impulsivity by distress tolerance. We hit OK. Oops, I forgot to ask for something. Regression, linear, and in our statistics, we can ask for the covariance matrix. Now this is actually an asymptotic covariance matrix, which means it's not the correlation or covariances between the variables, it's the correlations and covariances between the variables within the model that you run. In other words, it's the relationship between all of the slopes and the intercept in those models rather than the true variables. And it's the variance of those slopes and intercepts. I'm just going to grab this and scroll down to our table here. This is our covariances, variances, and covariances, okay, within our model. And you want to make sure that you get the covariances, not the correlations. So we need the covariance of our x slope. That's also just called the variance of your x slope. So we would go to our x slope is what? What is our x slope again? Anybody? It's this, right? Impulsivity. Okay. Let's grab that and copy it. So the covariance of our x slope is this. Hit enter. Next we need the xm slope coefficient variance. That's the same as the x slope coefficient variance. So let's get the variance of our interaction slope. And that's this one, right? And it's right here, actually. Seems that SPSS is, oh, there it is. Yeah, it's got it there. So we click on it, Control C, we flip back over, Control V, hit enter. And then the last thing is the covariance between x and m. So x was what? Impulsivity, and m was distress tolerance. Let's click on it, hit Control C, plug that in, we hit enter. So let's blow this up a little bit. Oh, it's already at 100%. Let's go to 150. So we can see this line is actually the relationship between impulsivity and our predictor. And you can see that on some portions of this line, that relationship is positive right here, right? And at some point, it actually becomes negative. At some point, impulsivity negatively predicts alcohol problems. And that never occurs at high levels of M, right? It does occur here. We will finish up, but we're running out of time. We will finish up talking about regions of significance next time. For right now, the most important thing to note is this. If we look over here, we can see that at this spot right here, a flip, right? That when distress tolerance gets so low, and in this case, it's right at 0, roughly, we see a change. And what that change really means is that distress tolerance is or impulsivity is no longer significant, right? Okay, let's call it a day. There will be homework for next week. I will get that homework up. I will get your homework for today graded, and I will get your homework for next week graded by Thursday, so get it submitted on Thursday. The exam will then be up on Thursday. You'll have 2 weeks. If you have questions, problems, you should email me. But I want to make sure that you guys are good to go with the interactions and such, or with plotting interactions before you start working on that exam. So I would not start the exam. You've got 2 weeks to do it. I would not start it until you've gotten your homework for next week back from me. And I will do my best to get it back to you on Thursday. Bear in mind, I'm going to be in a different time zone. So, all right, that is it.